Hi, everyone. My name is Leah Vargas, and I'm a product manager working to improve the Windows recovery experience when issues occur. Welcome to the session From Panic to Productive, Point Time Restore in Windows. First, let's learn about what is Point Time Restore and how does it work. Point Time Restore is a new Windows recovery capability that allows you to quickly revert a Windows PC to the state it was in at a previous point in time before an issue hit the system. This is a feature that can be used for one-off issues all the way to widespread outages. Advanced troubleshooting, re-downloading apps, or reconfiguring settings after a reset is not needed with this feature. This feature builds on existing snapshot technology known as Volume Shadow Copy Service, or VSS. Restore points are captured automatically at recurring cadence and stored locally on the disk. Configuration is available within the recovery page of System Settings, and the restore is available in the Windows Recovery Environment, or WinRE, which you can see in the UI on the right side of the slide. And it's located within the Troubleshoot page. This feature is currently in preview for Windows Insiders. For the restore points, the scope includes the entire volume where the OS is located, as shown in the screenshot. We are snapshotting everything on this volume, including changes to system files, settings, and user data. We are excluding the EFI system partition from being included in the restore point. Restore points are captured in the background via a scheduled system task, and I'll talk more about how users can configure the scheduled task in a few slides. Deletions can occur under a few circumstances. First, if the maximum space for restore points exceeded, or the device maybe reports low free space conditions, or VSS encounters a condition that prevents it from preserving data before it's overwritten, which is in rare cases, such as insufficient disk space, failure to allocate memory, inability to expand the disk area quickly enough, or if there's underlying write errors. Also to note, deletions always occur as needed starting from the oldest restore point to the newest. VSS restore points can be enumerated or deleted using the command line tool VSS admin. Some of you may be familiar with a Windows feature that has been around for a long time called System Restore. And might be wondering, how is this feature different from System Restore? While both Point Time Restore and System Restore use Volume Shadow Copy Service to revert a device to a previous state, Point Time Restore introduces a modern approach and focuses on reliability and a broad range of issues. Point Time Restore is triggered by a scheduled task, so restore points are captured automatically at a consistent time interval. Whereas in System Restore points are only event-triggered or manual. Point Time Restore enforces a max retention period of 72 hours for each restore point, whereas restore points for System Restore are on the system for an indefinite period of time, making it harder to predict the behavior. The restore scope includes the entire volume with the OS, whereas app and user data can be filtered out in System Restore, which sometimes can leave the system in a torn state, which is problematic. Point Time Restore integrates with the storage reserve to minimize storage impact. It does this by tagging restore points for the hard reserve. Restore points will be evicted from the hard reserve if the reserve is needed for critical system events, such as updates. Restore points will persist on the system once evicted from the hard reserve, granted there is enough storage space to store them outside of the reserve. If not, they'll be deleted from oldest to newest. And last, Point Time Restore is designed for robust remote management capabilities, such as triggering a restore and configuring the feature remotely from a management plane, which we'll show you a demo of soon. This will help ensure that Point Time Restore can be used at scale for your organization. Let's review key behaviors, limitations, and how this feature can be configured. First, we want to highlight implications this feature has on system storage. VSS storage is shared with other tools that use VSS, such as System Restore or third-party rollback software. And so there's no way to properly tell how much storage in total is being used by each tool separately. VSS has a max built-in space limit that it can use on a system. This limit is equal to the max usage configuration for Point Time Restore, which we'll talk about soon. To complete a restore, the device must have at least as much free space as the total size of all restore points. So to maximize usability of this feature, there are a few things you can do. First, if restore points, let's say, take up a total of 3 gigabytes on a system, you should ensure that that device has at least 3 gigabytes of free space for the restore to complete successfully. Next, you can avoid combining point time restore with other VSS backup tools that may compete for space. And last, if needed, you can increase the max usage for restore points from the default. Depending on the max usage value, some or up to all of the space used by restore points will already be reserved on the system using the existing storage reserve, and therefore won't appear as additional disk space being used up. It's important to be aware of risks and limitations associated with point time restore. First, since this is a rollback solution, there is just naturally going to be data loss. Point time restore is a comprehensive recovery solution that reverts the entire system, including user files, applications, settings, passwords, certificates, and keys to the selected restore point. So any changes made after the restore point will be lost. Data stored in cloud services such as OneDrive is not affected. And that's why it's recommended to use OneDrive to store data and documents. There are a few ways the capture of a restore point can fail. It can fail due to disk space limitations, a heavy I/O load, or an unstable VSS writer. Then the restoration of a system can fail, again, due to disk space if there's low free disk space, or maybe modification of EFS encrypted files, or if there's sudden power loss during the restore, if there's a reboot mid-restore, or a corrupted file system. For devices with multiple volumes, only the volume where the OS is located is restored. Last, you should know that restoring can revert recent security updates or policies, so we don't block restores across quality update boundaries. So keep that in mind for your organization. To configure this feature, there are 4 settings that are only configurable by local admins. You can see the UI on the left within the system settings, recovery, and then point-in-time restore page, and then a table outlining the associated default and options on the right for each setting. First, there is the feature enablement and disablement. By default, this feature is on for Windows devices running Home Edition or Unmanaged Pro device. There's a nuance here that in order for the feature to be on by default on a device, the total disk size of that device must be 200 gigabytes or greater. However, if you would like to still enable this feature on a device with a smaller disk size, you can do so if desired. The feature will be off by default for devices running Enterprise Edition of Windows or Managed Pro devices until the feature update in 26H2, and then it will be on by default. Something to note is that turning off the feature will not automatically delete all restore points. It will simply prevent new restore points from being created, and existing restore points will naturally age out due to their retention period. Next, restore point frequency is how often restore points are being captured on the device. By default, the interval is every 24 hours, but this can be configured to be more often if desired. Next, restore point retention is how long restore points are able to exist on the system before they are automatically deleted or cleaned up. And so the default here is the maximum of 72 hours, and this can be configured to be shorter if desired. Now, the last configuration is the max usage limit, which I had referenced earlier. This is the total space limit for all restore points on your system captured by VSS, including from other tools. And the default is 2% of the disk. This can be configured using the slider within a minimum bound of 2 gigabytes and a maximum bound of 50 gigabytes. Retention and frequency will only be configurable by devices running the Enterprise editions of Windows. Okay, now we're going to walk through a demo of how an end user can recover their device using point-in-time restore. Let's say we're an end user who's been experiencing multiple system crashes, and we are booted into WinRE. Here is the WinRE landing page, and here we can see the troubleshoot option. So we're going to select that, and then we see point-in-time restore as the first option. So we'll select this, Now, as an end user, I need to enter my BitLocker recovery key. So if I don't know my BitLocker recovery key, I'm going to visit the short link called aka.ms/recovery key FAQ to find my BitLocker recovery key using my recovery key ID, which is listed here. Now, once I find out my recovery key, I'm going to enter it in this field and select Continue. Now here, I can see all the restore points that are available on my system in order from newest to oldest. I'm going to select the most recent restore point to restore my system to because I'm confident that this was before the issue hit my device. I now see a warning page that basically explains to me that all changes on this device after the restore point will be lost and lists specific types of changes that I'm going to lose. This includes data, documents, downloads, installed apps, configurations, system settings, and other changes, passwords, certificates, and keys. And I also see that data stored in cloud services like OneDrive won't be lost. By continuing, I acknowledge the risks and limitations with this feature, which may include data loss. I now see a final confirmation page that tells me that this action can't be undone. And I see a warning message, again, noting me that all changes made on this device after the restore point will be lost. And I'm able to see the restore point that I selected by its timestamp and the OS version that was running during that restore point. I'm also told to keep my device powered on during the restore. And now I can continue and select Restore to kick off the restore. I see that the restore is preparing, and then it's in progress, and I'm booted back into my main operating system. Now, as you can see, this restore happened really fast, and that was for demo purposes. We're not trying to suggest here that a restore is only going to take a few seconds. The restore time in reality will vary on several factors, including how large the restore point is and the specs of the device that you're using. But we can say that this will be faster than doing a push button reset. Next, you'll see a preview of remote management for point time restore, which is coming later this year, so stay tuned. To note, the Intune UI is a prototype for demo purposes only. So here we have a scenario where one of our Intune managed PCs of an employee receives a faulty driver update, causing it to repeatedly crash and become unusable. Now the device has booted into WinRE, and the end user sees this message, informing them that their IT administrator is working on a solution. The user is instructed to keep their device powered on so the recovery process can proceed. Because this device is managed by Intune, it automatically connects to the network. The new Intune remote management plugin then establishes a secure connection with the Intune service, enabling a remote intervention. Now we're going to see what this looks like from the perspective of an IT admin in Intune admin portal. Here we can see the Windows recovery section in Intune, an overview of their device status, the remediation action status, and the WinRE preparedness state of how ready WinRE is for remote management. Once connected and authenticated, the IT administrator can then navigate to the Recovery Devices tab to view all the devices currently in need of recovery. The IT admin can then identify and select the correct PC to remediate. With organizational policy requiring data to be backed up to OneDrive, the risk of data loss is minimal. The most effective and scalable way to recover this device is to use the new point-in-time restore feature to roll back the employee's PC to a previous restore point before the issue occurred. Here, the IT admin can view the list of restore points that are available on that device along with the OS version that was running during each restore point. The IT admin can select a restore point that was captured before the issue hit the device. The IT admin confirms to start the restore, and the device can begin the rollback process. And as you can see here in remediation status, this action is in progress. As soon as the point-time restore command is received from Intune, the employee's PC begins the restoration process automatically. And now we can see what this looks like from their point of view. So here, from the end user, we can see that the restore is in progress. And then once the process is complete, the employee's PC is restored to its previous stable state before the faulty driver update, and it can boot back into the main operating system successfully. And now the user can log in and go back to where they were before they started experiencing the issue. Okay, great. That wraps up the demos we have to show you. Now we'll conclude the session with some best practices you should know and a call to action. In summary, some best practices to keep in mind are to first, do not turn off the device during a restore, as that would leave the device in a corrupt state. And we try to make this very explicit in the UX, as you just saw in the demo. It's recommended to plug the device into a power source during the restore to prevent the device from dying mid-restore, which again can leave the device in a corrupt state. Next, you should monitor and manage storage. You should ensure sufficient free space on the system for both restore points and additional space during the restore process for a successful restore experience. Next, you should ensure reliable access to BitLocker recovery keys for end users and help desks. End users will have to enter their BitLocker key if the restore is not triggered remotely from MDM. And last, you should perform a post-restore validation of critical apps, security agents, and policies. Our call to action here is for you all to validate point-time restore in your environment and pressure test it with real scenarios and tell us what works and what doesn't by providing feedback. You can try the preview version of this feature in the latest Insider build today, and it will be generally available soon. If you run into issues or have suggestions, please use Feedback Hub and file under Recovery and Install, and then the category Point-in-Time Restore. Submitting feedback there ensure logs are captured and routed directly to the engineering team working on point-in-time restore, and the team truly values your feedback and uses it to refine the feature for our customers like you. Here are a few resources you can visit to learn more about point-in-time restore for Windows. Point-in-time restore is meant to give customers like you a fast and reliable way to recover your devices when the unexpected happens, instead of just jumping straight into reimaging. Thank you all for your time today and helping us further transform Windows recovery from panic to productive.